Algebra 2, we're going to talk about 5.3 here. This is polynomial functions. Now, this one's going to be kind of a longer one because there's a lot of information that I think I started talking about in one of the other lessons, but we have to kind of talk about here as we go through all of this. Guys, a polynomial function is going to be something that's in one variable. And this is the very general form of what they call a polynomial. A sub n x to the n plus a sub n minus 1 to the x minus 1. All that mambo jumbo right there basically means that it starts off with the highest power, goes to the next power, the next lowest, and the next lowest, and so on and so on and so on. So the powers are always in a descending order. We already talked about this before. That is called standard form. Now they say it's general form on the bottom. Okay, but it basically highest to lowest powers. Now, some other things that they talk about in this particular lesson is that all of the coefficients, the things in front, right, a sub n minus 1, all the way down to the constant a sub 0, they have to be real numbers, and any of the exponents that you have, where n is a non-negative integer. So you can't have negative exponents. That's big. Real number coefficients, integer, positive integers for exponents. And so they have a couple names for some of these. And so when there's no power, now we have degree. So degrees are the powers, the highest power. So when the highest power is 0, so there's no x's, you see, that is called a constant. When the degree is 1, it looks like a line, right? It's linear. So for x, that's x to the first power minus 9. So it has both an x and a constant. It can have just x's, no constant, and still be linear because the highest degree is 1. Then we go to 2. 2 is a degree of 2. That's called a quadratic, and that is your parabolas. So 5x squared minus 6x minus 9. It has all of the other parts, maybe some of the other parts. It does not have to have everything, but that would be the highest power is 2, so therefore the degree is 2. In a cubic, the degree is 3. Highest power is 3, and then fourth, it'd be a quartic, 5 would be quintic, things like that. And what they also want to talk about is something called a leading coefficient. And it's important that we talk about the leading coefficient as well because it does help us identify how polynomials will react. If they open up, they open down, things like that we're going to talk about soon. So, I have this polynomial here. We are going to name it, we're going to name the degree, and we're going to name the leading coefficient. So, I think first we have to recognize that is it a polynomial? Yes. It's a polynomial because 5, negative 4, negative 8, negative 4 are all real numbers. 3, 2, 1 are integers. They're positive, so that's good. So this is a polynomial. Second, I'm going to say that the leading term, because it's in standard form, highest to lowest, the leading coefficient is a 5, and the degree is 3. And if I say that the degree is 3, I can look at this chart, you may want to write this down, and I would call that a cubic. So as we talk about this, you're going to have homework questions that say, is it a polynomial, yes or no? Some examples of non-polynomials. So you'll have x, think of this, 5x to the negative 3 would definitely not be a polynomial because it has a negative exponent. Another giveaway for a non-polynomial is if you had something like 8 over x. You don't divide by x. That would result in negative exponents. So be very careful on that. So the next thing I want to talk about is just evaluating functions. And you've done this since Algebra 1. You've done this for a long time now. That if I started off with a function, f of x, and it equals 2x plus 3, can you tell me the value of that function at 1, negative 3, h, x plus 2? I think you should be able to. So remember, when we're doing function notation and we're evaluating, I am going to take out the x that was here, and I'm going to put a 1. which means anywhere in this particular function, doesn't matter if it's 2 terms, 8 terms, 1,000 terms, every time you see an x, you will put a 1. So I'm going to try to color code this so that you guys can see this. I'm going to take x out, and if I take x out, I'm just going to leave this hole. And in that hole, I am going to place its new value, 1. So now I can start to evaluate. 2 times 1 is 2, plus 3 equals 5. I can do the same thing with f of negative 3. It's still 2 times something plus 3. But what is that new thing? That new thing is a negative 3. So now I get negative 6 plus 3, which is negative 3. If I distribute or multiply. It doesn't matter if I change it with a number or a variable or an expression. X plus 2 is an expression. It's the same thing. I'm still going to rip out x. And when I rip that x out, it leaves that hole there. And inside that hole, I am going to put whatever is inside the new place, which is h. So what I did on this particular problem is I changed the value or the function itself to be, instead of f of x, it's f of h's. It's made up of h's. So it's 2h plus 3 as the new function is what it becomes. So looking ahead to the last problem on here, I am still going to rip out the x, and I have to now replace it with what was in that set of parentheses, which is x plus 2. Then just evaluate. That's 2x plus 4 plus 3. So I get 2x plus 7 is the new function. Okay, the next part is actually just for your general information. There's actually some really cool things. When you're talking about different degrees, every time I add a degree, it changes the way the graph looks. When you have a degree of 0, they are going to all be horizontal lines. But as soon as you add a degree and make lines linear, as in you have a slope then, the lines are still they're straight, but as you can see that they'll have a positive and actually sometimes a negative slope. So they'll actually go both ways. So you could have a line that goes like this. Then we move up to a degree of 2, which are parabolas. And guys, you should already know this. Parabolas open down or they open up. Remember, according to what A is. So we could have a U shape up or a U shape down. Cubic adds another twist. So every time I add a degree, I'm adding a twist. So when I went from degree 1 to degree 2, it went from no curve to a 1 curve. I add another degree, I got 3 curves. 1, 2, 3. If I have 4th degree, I have 4 turns, or actually 3 separate turns. It's always 1 less than the degree. So when it's to degree 1, there were no turns. When it was degree 2, there was 1 turn. When there was degree 3, there are 2 turns. Boom, boom. When it's degree 4, there's 3. 1, 2, 3 turns. When it's a degree of 5, I get 4 turns. 1, 2, 3, 4 turns. So every degree, and each one of these does have a positive and a negative. You're going to have to take this, copy this down, so that you got a quick reference of what the shape should look like. Now, you don't have to necessarily remember everything about it, because really the biggest thing that you're going to take away from here is called end behavior. End behavior, guys, is not what happens in the middle. It's what happens at the very ends, as your graph gets larger and larger and larger as x goes to infinity. So it's really weird to say infinity, because nothing that we can ever point to says infinite. Nothing concrete. So it's this idea that if I let x go on forever, what is y going to do? So remember, f of x is y. Now, I do write these slightly different, and I'm going to go back to this last page. This is a nice, neat little chart that says, if your degree is even and your leading coefficient's positive, all of your graphs will end up following this exact parabola. There will be something different that happens, in the middle here someplace, as in it may come down and then back up. So there could be very many different switches or higher degrees, but this works for degrees of 2, 4, 8, 6, 22, all of that. And if it's positive, the ends are going to always be going up and up. If it's negative, it will always go down together. So even with a negative coefficient, goes down, both of them. Versus an odd, so 1, 3, 5, 7, 9, etc. If it's positive, it starts low, ends high. And if you think about it, it kind of follows what a positive sloped line would be. So a positive slope line starts low, ends high. A negative slope line starts high, goes up forever, and then goes down forever. So this is what I'm talking about if I go back to here. If I take a look at these graphs, this graph, as x gets very, very large, the y values will go up, 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 up. So this is x goes to infinity, y is going to infinity. As x goes to negative infinity, y is going to go to negative infinity. So this is how I want you to write these. And I'm going to make myself a nice little space here. So write this down, because this is how I want your answers to be. As x approaches infinity, even a positive infinity, f of x is approaching where? As x approaches negative infinity, f of x is approaching where? And those blank spaces are what you need to fill in. So particularly on this one, as x goes to infinity, y is going to positive infinity. As x goes to negative infinity, y is going to negative infinity. If I switch to this graph, as x gets very large, you can see that y is taking a dive. So as x goes to positive infinity, y, or f of x, is going to negative infinity. As x goes to negative infinity, y is also going to negative infinity. So that's what you would put into these spaces here. And then, again, this kind of sums that up. It makes it a little bit easier for you to understand or see that. The cool thing is that you don't actually need the graph to make those assumptions because it's part of the polynomial. Okay, so this is the example from the book, and it says, for each one of these, describe the end behavior, determine whether it represents an odd or an even polynomial, and then state the number of real zeros, aka how many times does it cross the x-axis. Now, if I want to describe the end behavior, I'm just going to look at the graph. And okay, so I will actually say, as x approaches positive infinity, x or y is going to negative infinity. As x approaches negative infinity, y is also going to negative infinity. I don't necessarily like the way the book does this. I actually rotate it the other way. So as x approaches positive infinity, f of x is going to negative infinity. As x approaches negative infinity, f of x is approaching negative infinity. It's going to negative infinity in both directions. What's your degree? Your degree is always one more than turns. 1, 2, 3. It's got 3 turns. So 3 turns means it was a 4th degree polynomial. And so if it's 4th degree, that means it's even. And it crosses the x-axis, 1, 2. These don't cross. So there are 2 real solutions. And so that's what you're going to have to do in your homework. Okay. We're also, so you can do the same thing on the next one. It starts high, ends low, which means it has to be odd because evens go together. And it's got 1, 2, 3, 4. So if it has 4 turns, it is the 5th degree. It crosses 1, 2, 3, 4, 5. 5 solutions, real solutions. Better put that because it wants to know real. And if you look here, as x approaches negative infinity, so as x goes to negative infinity, looks like y goes woo off the graph to positive infinity. As x goes to positive infinity, this way, it's going to negative infinity for f of x. So, I would like you to do all of these problems. I whited out the problems I do not want you to do. So the first 3 problems, I need you to state the degree, the leading coefficient, and is it a polynomial? Yes or no? Okay, make sure it's in standard form. 5 and 6, 7 and 8, they are all about evaluating the functions. In 5 and 6, they want you to put in 5 and -4 into these equations. And then in 7 and 9, they want you to make sure you use the correct function. This is c of x. This is d of x. So if you can see, you want to put y cubed into this function. In this problem, you have to do a little bit more work. You have to take c of 4a, so you got to put 4a into here, then multiply that function by 6. 6 is on the outside of the function. And then for this one, d, this is function d, you need to put 3a minus 5 into here. Now careful, you have to square 3a minus 5, which means you have to FOIL that before you multiply it by 2. And then these two follow exactly what we just did. Have a great day.